Hello, this video is about solving systems of equations by substitution. And what we're going to do is we will have two equations and we'll be able to eliminate a variable just by substituting one equation inside of the other equation. So let's get started. When you're solving systems of equations through substitution, you're going to choose one of the equations to solve for one of the variables. You're going to get that one variable on a side by itself. For example, it would be nice if the equation was in the slope-intercept form because as you can see in this form, the y is on the side by itself. But you don't always have to, or should you always solve for the same variable. It just depends on how the equation's set up. Sometimes it's already solved with one variable, so you don't have to always solve for y. You substitute the expression obtained in step 1 into the other equation. Solve the resulting equation. Then you're going to substitute the variable found in step 2 right here. You're going to substitute that variable back into step 1 in that other equation and solve for the remaining variable. So let's see how this looks. Here I have two equations. Here's equation 1 and I have over here equation 2. All right. I can see that in my equation 2, it already is ready to substitute. I have a variable by itself. This y is already by itself. I can see that this y equals a negative 2x plus 3. So what I'm going to do is substitute this part of the equation, negative 2x plus 3, I'm going to substitute it right here in equation 1 for y. So let's start this substitution. I have a negative 3x. I'm going to rewrite the whole equation so you can see the substitution right underneath. Negative 3x plus 2, negative 3x plus y equals a negative 2. Then I'm going to make my substitution here. I put in a negative 2x plus 3, and then I'm going to write the rest of the equation like it already appears. Notice how I put in a negative 2x plus 3 in the place of the y right above. And now that I've made that substitution, I have eliminated the y variable here, and I just have my x's. So I'm going to combine my like terms. A negative 3x minus 2x plus 3 equals a negative 2. I end up with a negative 5x plus 3 equals negative 2. I'm going to subtract subtract 3 on each side. I end up with a negative 5x equals a negative 5. Divide by negative 5 on each side. And now x is going to give me a positive 1. So I have my x. All I'm going to do is go back and plug it into an equation and get my y variable. Well, I like equation 2 because it looks a little bit more simple. So I'm going to plug my x into equation 2 right over here. So I've rewritten the equation y equals a negative 2x plus 3. I'm going to just plug in this 1 right here where the x would be. And let me change colors so you can see that substitution. And I'm going to go ahead and solve. A negative 2 plus 3 equals 1. And so I can see that y also equals 1. So the solution to this system is 1, 1. And that means I have one solution. Now, a good thing to do is always to check your solutions just to make sure that you're correct. So I'm going to do that. In equation 1, I'm going to go ahead and make my substitutions. Negative 3 times 1 plus 1, see that substitution there, equals a negative 2. And that does check out as correct. All right, in my equation 2, I have a y, which is going to be 1, and that equals a negative 2. That's going to be times 1 plus 3. So, once again, I have 1 equals 1, and that checks out. So I know that my solution is correct. Let's try another one. So here, I can see that it is not ready for substitution, neither equation. So I'm going to have to change one of these equations, equation 1 or equation 2, into a form that is easily able to substitute. So I'm going to have to solve for a variable. And I can see that equation 1 is easier to maneuver to get a variable by itself. So I'm just going to subtract x on each side. And when I do that, I end up with y by itself, which is what I want, equals a negative x minus 2. Now it is ready to substitute. So I'm going to take negative x minus 2 and put it right here where this y is located, because y equals a negative x minus 2. It's going to go right here. So let's go ahead and make that substitution. So we have 2x minus 3y equals a negative 9. And I'm going to have 2x. I'm going to go ahead and make my substitution now. A negative x minus 2 equals a negative 9. I'm going to go ahead and use that distributor property through there. I see I have a negative 3 that's got to be distributed all the way through. Remember, it's multiplied by everything in parentheses. So as I simplify, I end up with 2x minus, well, it's going to be a negative 3 times a negative x. So that's going to end up being plus 3x. I have a negative 3 times a negative 2, so that's going to be plus 6 equals a negative 9. 2x plus 3x is going to be 5x plus 6 equals a negative 9. I'm going to subtract 6 on each side. So now 5x equals a negative 15. Once I divide by 5 on each side, x is going to equal a negative 3. So I have my x coordinate. I'm going to go ahead and plug it into one of the equations, and I choose equation 1 because it's simple. And I'm going to find my y coordinate. So equation 1 says x plus y equals a negative 2. So if I put my x coordinate in, negative 3 plus y equals a negative 2. I'm going to add 3 on both sides here. So then y equals a positive 1. And I have my solution to this system of equations. My final solution is negative 3, 1. That means I have one solution to this system of equations. Now, I always like to check my answers here. And so what we do to check our answer is we take that negative 3, 1 and put it back in both equations just to make sure it checks out. So equation 1 was x plus y equals a negative 2. So I'm going to put in my x coordinate, a negative 3, plus my y coordinate, 1. and that's going to equal a -2. So -3 plus 1 is a -2, and that checks out. Let's try equation 2. It's 2x minus 3y equals a -9. So I have 2 times my x coordinate, which is a -3, minus 3 times my y coordinate, which is a 1, equals a -9. So 2 times the -3 is a -6, and -3 times 1 is a -3, and that does give me a -9. And so that checks out. I know that my solution is correct. Let's try another one. Okay, for this one, we want to make one of these equations easy to substitute. So both of them look very similar. If you look, I have x plus y equals 4, and then x plus y equals 1. Something should look a little interesting to you here, looking at I've got x plus y here and x plus y there. And we can use substitution, but you should be able to see here that how can x plus y equal 4 and equal 1? So we should know right off the bat, since 4 does not equal 1, that this would be no solution. But let's go ahead and work it out so that we can prove it. So I'm going to change equation 1 into an equation that is easy to substitute. So I'm going to subtract x on both sides. This will give me y equals a -x plus 4. I'm going to take -x plus 4 right here, and I'm going to substitute it for this y here. So this is going to go right there. Let's go ahead and make our substitution. I have x plus y equals 1. So now x plus a -x plus 4 equals 1. Oops. Equals 1. Okay, I like the substitution just to be a different color. So as I can see here, x plus -x, that cancels out and gives me 0, plus 4 equals 1. So 4 equals 1 turns out just like I said before. 4 does not equal 1. So that is why it is no solution here. I do not have a solution because this is not a true statement. And whenever you end up with an untrue statement, that means you have no solution to this system of equations. Thank you so much for watching. What we did was solve systems by substitution today. So for a little bit more viewing and just to slow it down and pause it, or just for a different voice, you can check out this video here. I also have a number of solutions to systems of equations, solving systems graphically, and also solving systems with elimination. I hope you enjoyed, and thank you for watching.